So yeah, we are recording this, and I will distribute the link. It'll be via our newsletter, which will go out most likely later today. So I just want to welcome everybody and say thanks for coming along. If you haven't already, please mute your microphone. And if you're experiencing any technical difficulties or have questions, I just ask you to write them in the chat. We will be answering questions at the end of the presentation. So we've organised this short webinar as part of our strategic education and capacity building program. The aim is to foster a shared understanding of issues and solutions for best practice management of urban waterways, and we always welcome suggestions for webinar topics, so please get in touch with me if you've got an idea or a presentation you would like to share. The topic today is fresh ideas for restoring a stinky creek, or stinky creeks, and it's about the restoration of Carina and Kareela Creeks. It's presented by Philippa Biswell from Sutherland Shire Council. Philippa has worked in the Environmental Science Unit on environmental projects, often dealing with contamination issues, acid sulphate soils and erosion, as well as the associated aspects such as water quality that tie into these issues. She has been working in this role for the past 16 years. We're excited to be sharing this case study with you. Philippa's work, with the assistance of Nathan Varley, who many of you will know, has provided an understanding of the sulphate cycle in creeks, leading to a methodology to restore stinky creeks, which Sutherland Shire Council is using at multiple sites. This is roughly a 30-minute presentation, and as I said, there'll be a Q&A after. Over to you, Philippa.
Okay, thanks, Kirsten. So I'm just going to share my presentation, so hopefully you can all see this.
Yes, looks good.
Okay, excellent. So, yeah, so we had two projects. Well, we started off with Carina Creek as the original project. And, you know, the object of that project, well, both the projects were to restore natural environmental flows in the tidal creek, improve the quality of the water, flora and fauna environments, increase the oxygen levels and reduce hydrogen sulphide concentrations in the water, encourage the reintroduction of nursery fish, invertebrates and other fauna. We needed to merge works with surrounding environment so it didn't stand out. And most importantly, we needed to keep costs at an economically viable level. We couldn't go spend millions of dollars on these projects because we just wouldn't get the benefits back from them. So to give you just a little bit of an overview of both the creeks, Carina Creek, prior to 1970, it was a tidal flats and mangrove. So that's this top video here, top photo here. So you can see there's a tidal flats there and you've got mangroves either side. The foreshore was reclaimed during the 1970s using uncontrolled fill material. So you can see that in the bottom photo. A rudimentary stormwater pipe was placed across the reserve, linking a stormwater channel on the western side to the dredged tidal channel on the eastern side of it. Grey mangroves populated the tidal channel, and casuarinas and pittosporum basically populated the area along the embankment after construction. So Kareela Creek, again, prior to the 1960s, was a bay with mudflats tidal areas. Again, it was reclaimed using uncontrolled fill materials to create a golf course. The red outline here is the man-made tidal creek that also connects to 150 hectare stormwater catchment. So it's one of the biggest catchments that we've got in Sutherland Shire. Again, the area is populated with grey mangrove, salt marsh species and casuarinas. So just to give you an overview of where they are in terms of the Shire and also Georges River. So here's Georges River going through here. You know, they're not that far away from each other. Both creeks have got residents living adjacent to them, and both residents and also visitors to the area have been experiencing severe intermittent odours for many years. The smell was described as putrid, sewage-like, diesel-like, which that's not very helpful to council staff. So to start off, we had no idea what it was. The other problem was we'd get a phone call, the smell is here, we'd get down there and the smell had dissipated. So it's really hard to pinpoint exactly what that smell was. Over a period of more like 3 years down at Carina Creek, we did a qualitative and quantitative research, and we discovered that it was hydrogen sulphide gas that was creating these odours. So just to compare the two creeks, both were reclaimed land, man-made creeks, both populated with mangroves and casuarinas. Salt marsh was present at Kareela Creek only. Carina Creek, the embankments are too steep for salt marsh to survive. Both had acid sulphate soils. Only Kareela Creek had regular stormwater flows, and because they have regular stormwater flows, they only experience seasonal occurrence of hydrogen sulphide odours, because during the winter months and the wetter seasons, the creek got flushed out on a regular basis with stormwater. Carina Creek, on the other hand, doesn't have a lot of stormwater influence at all, and therefore they got odours monthly on high tide periods. So so the residents down at Carina Creek were impacted by the odours much more than the residents at Kareela Creek. Both had a sediment berm or a sediment levee present, restricting natural tidal flows. We saw a lot of discoloration of the waters at Carina Creek due to stagnation and impacts of the hydrogen sulphide there. We didn't see that so much at Kareela Creek, again, probably due to the stormwater flows through that creek. And both had residents living in close proximity and visitors to the area. So you can see that both creeks were very similar. So we eventually discovered it was hydrogen sulphide, and that was discovered by accident. We took a sample of the Carina Creek water, we put it in a jar, we put the lid on, and we left it on the desk for a few days, forgot to do anything with it. And the water turned black. And when we took the lid off, we got the odour of hydrogen sulphide gas. So from that point on, we knew that we were dealing with hydrogen sulphide. So knowing that, we could go forward. So basically hydrogen sulphide, it's a colourless, dense gas with a characteristic odour of rotten eggs. It naturally occurs in creeks, swamps, swamp marshes and mangrove forests, and it's associated with the decomposition of organic matter. It is also associated with sewage and other anthropogenic influences, and that's why we were getting the the descriptions of sewage smells, diesel smells, those kinds of things. Anyway, we tested for sewage and we ruled that out, so we knew that it wasn't that. We also tested for diesel and hydrocarbons as well. So give you an idea of what Carina Creek looked like prior to construction. So we've got the photo here on our left. We've got blackened areas that were typical of sulphide reducing bacteria reacting with metal oxides in low oxygen environments. So we produce these insoluble iron and manganese oxides, which are these black patches around the out areas. In the middle, you can see it's milky white, and we've got a close-up of that on the right. And the milky white appearance of the water is typical of aluminium dropping out of solution at pHs between 5 and 6. So the stagnating of the water caused the pHs to drop. We also got pockets of water trapped. Now this little pocket here is actually where that rudimentary stormwater pipe entered into. So we got sort of like gas bubbling up as well through the water. So we got very low oxygen levels there, very high hydrogen sulphide levels and insoluble iron magnesium oxide, high levels of that. So it came out as very, very black. We also got occasionally on an outgoing tide, water would turn an iridescent green, which could be sulphate, nickel, arsenic coming out of solution. Aluminium at very low pHs can turn the water a iridescent green, but this water was, because the tide had just come in, it was at a higher pH, so we know it wasn't aluminium. The other thing that we regularly got was iron flock bacteria, and these are the upper reaches of the creek. So right up in the upper reaches where the tides very, very rarely went to. Iron flock bacteria is an iron oxidizing bacteria and derives the energy needed to live and multiply by oxidizing dissolved ferrous iron in soils or water. So it's very typical in stagnant acid sulfate soils regions. And you can see on the right photo that it can actually occur as an iron flock that sits on top of the water as well. So the one on your left is sitting on top of soil, and the one on the right is sitting on top of water. So it can be quite harmful to invertebrates and the estuarine environment as well. So Kareela Creek, on the other hand, we didn't really see any of these discolorations. Occasionally we'd see a little bit of darkening of the water, but basically what there was upstream, above the sediment levee, the water table was kept at an artificially high level, which just helped to stagnate the waters and get the sulfate reducing bacteria multiplying. On the photo on the right, so you can see clearly that we've got this nice deep channel. So this is looking upstream. So we've got this nice deep channel that flows in from the Georges River, and then it hits this V-notch. Well, apparently many, many years ago, council dredged this channel and stopped there. Really not sure why, but you know, it possibly wasn't this high when they originally dredged this channel, but it has silted up over time, and you can see that there is a clear stretch of sediment through here. So it was an 120-metre sediment levee. The tide wouldn't go over that point until it reached over 1 metre AHD, so quite high. So just to compare the two, at Carina Creek we have a 25-metre sediment levee, and Kareela Creek we had a 120-metre sediment levee. So the sizes of the sediment levees were quite different, but they both still had the same effect. So basically, now that we know that the odour is caused by the generation of hydrogen sulphide and that the sediment levee was the main issue, we needed to understand how the sulphur cycle in the tidal creeks actually worked. So we sort of looked more into this. Basically what we found out that was the water at the upgradient part of the creek becomes stagnant with low levels of dissolved oxygen and low pH. The stagnated water has high content of organic carbon from the leaf litter from the mangroves and casuarinas. The sediments, both creeks have been classified as the sulphate soils, and therefore there would be a contribution of sulphate from those soils. As that organic matter from the mangroves and the casuarina decays under low oxygen conditions, that sulphate reducing bacteria uses the sulphates present in the water and the organic matter to produce energy. Okay, sulphate reducing bacteria are anaerobic microorganisms that are widespread in anoxic habitats. So that's areas that are low in oxygen. Okay, so they thrive in those areas. Basically, a byproduct of the anaerobic bacterial action on sulfur compounds is the hydrogen sulfides. Hydrogen sulfide gas released slowly in ambient air, but it will release quickly when oxygen is rapidly introduced, as it does with a high tide. So in Carina Creek, every tide over 1.8 metres went over that sediment levee and released a hydrogen sulfide gas. In Kareela Creek, it was 1.7 metres. Okay, and how do we know it was 1.8 metres, 1.7 metres? Well, we put together basically a rudimentary system using white paint and wildlife cameras. We strapped the wildlife cameras to a tree, pointed it at another tree that's got some white markings on it, and then we just recorded the rise and fall of water over several days, up to a week. And hopefully you're all seeing this, and basically the water rises, the water falls. We can compare it to tide charts for that day that we recorded it. The cameras record the time of the movement of the water, and therefore we were able to determine that the sediment levee was sitting at 1.8 metres at Carina Creek and 1.7 metres at Kareela Creek. So pretty simple, didn't need an engineer or a technician to work that one out. So also, you know, we needed to learn a little bit more about the sulphide species, how they operate and work, and what their physical properties were. So there's basically 3 species of sulphide species present. Hydrogen sulphide is highly volatile, so it can easily change between an aqueous solution and a gas. And you get that rotten egg odour with the gas. It's readily soluble in water, water-based muds, and other liquids. Okay. Hydrosulphide is soluble in water, remains in solution, so it's really quite stable. It's not volatile, and it doesn't have an odour. And sulphide, similarly, it precipitates out at pHs above 7.5, but otherwise it's fairly stable and it doesn't have an odour. So hydrogen sulphide is the one that was problematic for us. And to see how it reacts in water, varying pHs. So you can see hydrogen sulphide, the sulphide species is in the form of hydrogen sulphide up to pH 1 to pH 7 or 8 roughly. So at a pH 7, we've got approximately 50% hydrogen sulphide and 50% hydrosulphide. So what we wanted to do is we want more hydrosulphide than hydrogen sulphide. So the aim of this project was to try and keep the pH above 7, preferably at 8, because between pH 8 and 12, mainly hydrosulphide is present. And that's really what we were trying to aim for. We also discovered that other influencing factors on the production of hydrogen sulphide was rainfall. So the rainfall actually raises the pH and pushes it towards that hydrosulphide form and lowers the amount of hydrogen sulphide available that can turn into a gas. Temperature increases the hydrogen sulphide gas production, so it hurries that up. So in summer, we would experience higher rates of odours. Wind direction, so has a big influence as well. So hydrogen sulphide gas is heavier than air, and it'll just sit on top of the creek. It'll sit low unless it gets pushed out by wind. Okay, so both Carina Creek and Kareela Creek are in a bit of a wind tunnel. So every time the wind's blown in the right direction towards the residents, then we would get lots more complaints as well. So one of the big issues that we had from the residents was the odours and the concern regarding the human health impacts from the hydrogen sulphide odours that they were getting on a regular basis. So council originally hired, then purchased an odorlogger to record atmospheric levels of hydrogen sulphide gas. Okay, so you can see here is the odorlogger unit, and down the bottom here it's got a little hole, a disc with a filter on it, and what it does is it draws air up through there and records the level of hydrogen sulphide in that sample of air that it takes. You can vary how often it does that. We had it set for taking a reading every 10 minutes and we'd leave them out for up to a week, so we could see sort of like the patterns over the days. On this side, we can see it's in a little waterproof case hanging in a tree. So we would put it above the water, above the sediment plug, so where the hydrogen sulphide was being generated. We'd also move it down towards the residents' properties so that we could record what they were experiencing as well. Just out of interest, these are the recommended hydrogen sulphide exposure limits from the Western Australia Department of Health guidelines. New South Wales don't have any guidelines, and so they basically directed us to the Western Australia guidelines. But you can see that the odour threshold, so that's when people can actually smell the gas, it's 0.008 parts per million. So it's very, very low. It's much lower than what our odorlogger could actually measure. So people can smell at really low levels, but at those low levels, they're not dangerous. You increasing concentrations could cause possible annoyance, headaches, nausea, and fatigue, but you're not going to get into any long-term human health effects until you get to 2 parts per million, which is quite high, and 2 parts per million at a exposure limit of 30 minutes. So if we go to the next slide, this is some of the results that we took using the recorded using the odorlogger. So this blue line down here are our peaks of hydrogen sulphide gas in air that we recorded. This peak here is our highest peak that we've ever recorded, and it's 0.4 parts per million. And as you can see, the next 10-minute cycle, it's dropped down quite a bit lower. So, you know, it's much less than the 2 parts per million, which is this line up here. So it was never going to be a huge, like a long-term health impact for the residents, but we, you know, agreed that it was a nuisance impact. But the other interesting thing that we discovered from this is we compared it to our tide. So this red line here is our high tide down to our low tide. And we could see quite clearly that the hydrogen sulphide was being released after a high tide of 1.8 meters and just prior to reaching the low tide. So we had a pattern that we could work with here. The other thing we needed to do was test for water quality. And if you guys have met Nathan, then you'll know that this is Nathan out in the field doing what he does best, sampling. And he also always has a little entourage of onlookers. So we've got a couple of ducks and magpies that just hung around, making sure he's doing his job properly. But we tested for all parameters of the water, and the most interesting ones were dissolved oxygen. So we can see here at the start of the high tide. So this was taken over a 1-day period. So we were getting a high tide above 1.8 meters. And you can see that we've got really low dissolved oxygen. A tide comes in and our oxygen levels improve. But up here, the green line and the blue and the purple line are what are the ANZAC recommended guidelines. So we're nowhere near the dissolved oxygen levels that we should have in a creek, but it was promising to see that, you know, tidal influence was increasing that dissolved oxygen levels. Similarly, we can see that with pH. So we can see that when pH is quite low, but when the tide comes in, it raises the pH of the water as well. So that was promising to know that if we could get regular tidal influences, we could keep the pH above this green line here is the 7. We're aiming for 8. We're somewhere in the middle there. So, you know, that was promising results to see as well. The other thing that we really wanted to test was for hydrogen sulphide in solution. We tried to take samples of the water and send them off to the laboratory to test for hydrogen sulphide, but because of the delay in getting it there and them analysing it, we never actually detected any hydrogen sulphide in any of the samples that we took and sent to the laboratory. So we approached ANSTO, and they came on board in 2017.
Hi Jess, it's Jack Slater here from Sutherland Shire Council. How are you going?
Good, thank you. How are you?
Yeah, good, thanks. I've just got a note here to give you a call about stormwater the property.
Who's talking to Jack? Okay, sorry. Okay, sorry about that. I don't know what happened there. Okay, so ANSTO came on board in February 2017, and they brought along the colorimeter and basically showed council staff how to use the equipment and which tests and monitors for hydrogen sulphide in water. Council purchased their own colorimeter, and then we went on and did a whole series of testing of the water to see what levels we were getting in the water and, you know, between tides and during tides. So this first graph that we've got here, it shows that the levels of dissolved hydrogen sulphide drops dramatically when high tide comes in. So this was taken over a week-long high tide period. So every day you'd get a high tide over 1.8 metres, and every day it would flush out the hydrogen sulphide just a little bit more until we basically got almost down to zero. The next slide, what we did was between high tide periods. So we measured this for 28 days in a row. And you could see that this blue line is the tide. We never actually got above the 1.8 metre threshold where we needed fresh seawater to come in. And as a result, we can see this red line is a hydrogen sulphide, and that is gradually increasing back up. So we could definitely see a pattern there. So it decreased during those high tide periods, and then it'll increase back up again. And it'll give us a recharge rate of the hydrogen sulphide. So all this information basically went into a study. So we engaged a consultant to look at possible solutions for Carina Creek, giving them all the information that we've found to date. So the option one was install a one-way weir system, create a freshwater wetland in the upper regions of the creek. And basically this one was to use stormwater to regularly flush out the hydrogen sulphide. This would have resulted in the creation of a new stormwater drainage system, and we would have had to remove hundreds of mangroves and replace them with casuarinas. So it would have had a huge impact on the existing environment. It would have cost a huge amount of money, and we decided it was unreliable. The stormwater flows cannot be predicted. So option two was to consistently dilute the concentration of hydrogen sulphide through regular tidal flows. And so and this way was to, cut through the channel the sediment levee somehow, and use the natural tidal movements to flush it out. So it would have been a lot more reliable. We know the tides are going to happen every day. So we went with option two, and our consultants designed a 100-metre long, 5-metre wide sandstone line channel. They also designed a weir, which was kind of our plan B. The channel location was designed to have the least impact on mangroves, and excavated sediment we deposited back into the stream, into the creek. There was a really deep section upstream that was one of the main contributing factors in releasing hydrogen sulphide, generating and releasing hydrogen sulphide. So we decided to fill that in to basically push water further upstream to have a greater effect of the tidal movement. Kareela Creek, we only ever explored the channel because we'd already done it at Carina Creek and we knew it worked. So in that one, we designed a 120-metre long, 5-metre wide. This one was an unlined excavated channel. Again, the location was chosen to prevent damage to existing mangroves. Excavated sediment could not be deposited back into the creek, so we had to dispose of it off-site. We already had an approval to dispose of dredge sediment in an offshore facility. So this is 10 kilometres offshore from Sydney. And so we spent a good 6 months doing the testing and putting in an application to extend that approval for off-sea disposal to include Kareela Creek as well. So we got that granted. So that was a good outcome for us. Fisheries permits were required for both jobs because we were going to harm mangroves, and in Carina Creek we were going to reclaim creek. So yeah, we needed to apply for those as well. So this is the Carina Creek HEC-RAS model designed channel. So you can see that, so the HEC-RAS design put in all our data and it spat out what was the required dimensions, length of the channel, size of the weir. The channel, which is this blue line here, extended way beyond the sediment levee, which is this yellow blob here, but that was designed that way to get the correct gradient and to allow a certain level of self-cleaning to reduce maintenance that was required by council. Okay, so the levels of this channel were designed to enable an average tide to inundate the upper region, so just up through here. At least we were aiming for once a day, hopefully twice a day, at least every second day at an absolute minimum. So I think there was 6 occasions where we'd only get inundation every second day. In a calendar year, every other day it was either once or twice that we'd get inundation up there. Okay, this blue section here is that deep area that I mentioned that we placed the excavated sediment. And this is the weir here. We didn't go ahead with it. It was just there as a backup. So the HECRAS model also modeled the expected water levels and extent in this upper regions on each tide. And it was there as a backup if that modelling wasn't 100% accurate. And we were finding we were getting odours being produced up in the upper regions because the water wasn't getting up there. So the weir would have held a little bit of water in these upper regions up here, just to keep the hydrogen sulphide in solution. So the Kareela Creek construction diagram was a lot more simpler. Basically, we measured the contours of the base of the creek, which is this dotted line, and the solid line is our finished line, our finished creek bed. So it was a lot more simpler diagram. We did it in-house. It was a cut and fill job, and again, it worked. So this is our dedicated survey team in Kareela Creek, measuring and surveying the bottom of the creek there. They did it twice, once before and once after the construction, to make sure we had the right levels. So just looking quickly at some photos of construction. So this is Carina Creek. They constructed 5 of these ramps into the creek so they could get their equipment in and out. And they tracked along these rocks. So this is the sandstone line channel. Under that is geofabric to hold it in place. The excavator and dumpy had to track over the newly laid sandstone because the sediments were way too soft for them to track on. So this is the excavator and dumpy in action, and then we've got the guys who manually lay the geofabric before the rocks were placed. The dumpy took the sediment upstream, dumped it, and then they had another big excavator to spread it out. Once that was filled, this is the upper section that we filled. We let it settle for 2 months because it was quite fluffy and looked quite high. So we let it settle, we let the natural tidal flows do its thing, and it gouged out shallow channels. So just before the big king tides of the summer season, Nathan and I went out there with some boogie boards and some garden hose and just spent a lovely day making those channels just a little bit deeper so that they could better handle the flow of the tides that were coming in. So Kareela Creek channel, similar excavator. The sediments were a lot firmer, but they still put boards down so they didn't sink in the sediments. Sediments there were bagged up and then taken off site each day. So because they're acid sulfate soils, they had to sit in the water for a little while so they didn't start oxidizing. At the end of each day, they piled them up, loaded them up onto a dumpy, and then taken to a nearest jetty and then onto a barge for offshore disposal. I've put a link in here for a video. So our construction crew put together a really good video. It's about 3 minutes long. If we've got time at the end of this talk, I'll play it. Otherwise, you can play it at any time in your leisure. And it just shows the process that they went to constructing or excavating the creek, bagging it up, and where the sediments went to in the offshore disposal. So, yep, have a look at that later. Okay, so just quickly going on, post-work photos. So this is Carina Creek. So before, this is the furthest downstream where we used to get really green water. Afterwards, it was always clear. And look, these changes we saw fairly instantly. Okay, the sediment plug through here we now have a lovely sandstone lined channel, and even today it's still working great. There hasn't been any sediment build-up or anything. In the upper regions where we're getting that iron oxide and the aluminium dropping out, that's where we filled it. We've got these really nice channels, and within 2 months of filling, we had mangrove seedlings that popped up, and they're still growing today. This is right up the top, not the furthest regions, but a fair way up the creek, and it was always black and awful looking. It's now clear. We had a chestnut teal duck families, quite a few of them move in pretty much straight away, and they've been back every year to raise their chicks. So, and we also get sprats and all sorts of other invertebrates up there, which we haven't seen for many, many, many years. So it's all very exciting. And this was the iron flock that was constantly present in the very, very upper regions of this creek. Haven't seen it since we've done the works, and we're even getting new growth of mangroves. So, you know, it really worked. Kareela Creek, same sort of thing. We had a basically high levels there, and when we opened it up, it all drained out. So this is the absolute upper region of the tidal channel, and so it should drain every day. Unfortunately, though, what we didn't predict was that in these buried sediments here, we had sulphate reducing bacteria that were extremely active. So you can test for that. You can send sample off to the laboratory and they'll tell you. And it was extremely aggressive, and the sulphate reducing bacteria, every time the tide went out, it would release the gases. So what we did was we built an embankment and we planted it out, and that has helped. That has stopped the odour problems. And I'm testing the sulphate reducing bacteria seasonally, and it appears that now that it's been exposed, that sulphate reducing bacteria is actually dying off. So hopefully we won't have any problems in the future. And this is the sediment plug, and we can see we've got a really nice channel there now. And very last slide, landscaping post work. So of course we went in there, pulled out the weeds, planted some species that were common to the area to try and stabilise embankment and reduce the amount of erosion, sedimentation through erosion of those embankments. We did, you'll see that we, at Carina Creek, we did try planting some salt marsh species, a bit of a experiment. It didn't really matter, it didn't really work all that well, so, but it was worth a try. Yeah, so that's it. Thanks for listening. If you've got any questions, like we're going to have question time now, but otherwise contact, send in questions to contact@georgesriver.org.au.
Thank you.
Thanks.
Thank you, Philippa.
Sorry,
Thank
and
you.
I went just a little bit over.
It's okay. We probably have time for a few questions. Philippa, are you able to see the chat?
I will be able to in just a sec. Yep.
I can see me. So I'm just wondering if people put questions in the chat, maybe Philippa, you wouldn't mind having a read and answering them?
So there seems to be only one question there.
Mm-hmm.
So what is the mechanism in channel upgrade works that no hydrogen sulphide generation in the creek? So it's just stagnated. Well, I mean, it'd be the same. So I'm trying to work out. So is that mechanism to determine whether to do works? I'm guessing that that's the question. Like, what would entice you to do works?
Deepak, do you have a microphone? Would you like to answer?
Yes. Sorry. Hi, I'm Deepak.
Hi.
Just trying to find out, is that the mechanism is just you promoting a flow through the channel? Is that correct?
Yeah. So
Okay.
obviously our one of our drivers for doing the works that we did was because it was impacting the residents. Aside from that, the stagnation of the upper end regions of the creeks had a detrimental impact on the ecosystem up there. So we were seeing mangroves that were dying. There was absolutely no life in the creeks, in the water upstream. So we never saw any sprats, no fish, no invertebrates. Ducks wouldn't even land on the surface. And yeah, we were just seeing casuarinas and mangroves dying. So, you know, that was another trigger for us to actually do the works.
Right.
Another question, were the sediments dredging tested before disposal? Let's see. Yes. Yeah. So the sediments in both the creeks were tested before we did anything with them. So we had to make sure that we knew that they were acid sulfate soils, but we had to make sure that they didn't have any high contaminant levels. To dispose of sediments at sea, it's quite a rigorous testing regime, and you've got to go through several series of testing. So you've got the basic contaminant testing, and then you've got to do nutrient testing. So that's when you sort of mix it with seawater and see what comes out of that to make sure nothing leaches out. So it was about 3 or 4 rounds of testing that we had to go through. So it was quite labor intensive, and did add a little bit to the cost, but the cost of that was offset by the reduced cost of disposing at sea. Okay, any quantification on hydrogen sulphide buildup rate in the creek? Is that post works?
Or during pre and post, yeah, if there is any.
So did we? Yeah,
is
yeah.
there
So
any
one
quantification been done, say, with the seasonal variation or with the tidal flow variation, or what are the parameters?
Yeah, we did. We did tidal, we did seasonal. I mean, because I only had 30 minutes, I only put up a couple of graphs, but we basically did a couple of years of testing in all seasons. So we did see a reduction in hydrogen sulphide generation in winter compared to summer, and that would have been the rise in temperature would have increased the generation of those hydrogen sulphide gases, and also hydrogen sulphide production in the waters. So yes, we did all seasons, and we did pre-tide. You saw that we did tested the hydrogen sulphide decrease. We also did just a test between high tide. So we'd go in after one high tide and test how much the hydrogen sulphide increased between subsequent high tide periods.
Right.
Yep. So we did a lot of testing in that regard.
Okay. For a similar creek, is that be applicable to similar creek, the one what you have done?
Yes. Yeah. It was similar. The difference was with Kareela Creek, is that we had that stormwater influence. We didn't have that at Carina Creek. And that kind of like threw a bit of a spanner in the works, because we sort of didn't know initially how to deal with the stormwater influence. But then we decided it's unpredictable, let's just rule it out. Okay, stormwater influence can only benefit the system, but it's not going to change our channel design. So we based our channel design just on tidal influence only. Yep.
Thank you.
All right. Okay, so next question is, are residents now satisfied that creeks along are no longer stinky? Yes, I have not had a complaint from Carina Creek or Kareela Creek since the works have been done. So I am taking that as they are satisfied. Are both creeks on council's water quality management program to collect further data and demonstrate the community that it's improving and enhancing over time? Kareela Creek is definitely on our water quality management program. We've also got a master plan for that, to deal with water upstream. to try and improve the quality of water entering into Kareela Creek, and also to work out when we need to maybe dredge again, if at all. Carina Creek, it's not on our water quality management program, but it doesn't mean that we don't pop down every now and then and just check on the creek to make sure it's going. We monitored Carina Creek for a year and a bit after the works, and so we feel that we've got sufficient data there to sort of demonstrate that that it worked, that the construction worked. Okay, next question. What were the estimated budget for the projects? I thought that was going to come up. Okay, so Carina Creek. So the first one we did, that came in under $250,000. So that was for design, about $40,000 for design, and close to $200,000 for construction. So basically, the most cost, the biggest cost for that project was the sandstone. That was a huge cost involved in that. Kareela Creek, on the other hand, cost around the region of about $140,000. We didn't have the sandstone cost there, but we did have disposal costs, which we didn't have, like disposal of sediment costs, which we didn't have at Carina Creek. So yeah, so that's the estimated budgets, which we thought were pretty good value for what the outcome was. Next one. Carina Creek has a sandstone riprap. Do you think the works could have been done without the sandstone? No, Carina Creek has got really soft sediments, and the sandstone line channel actually holds that channel in its form. Without the sandstone, it would have closed over by now, for sure. Because yeah, there's no structure in those sediments up there at all. Okay.
Great. Well, I think you've answered those questions very well. If anybody does have further questions, please get in contact with us, so George's Riverkeeper, and we can forward those on to Philippa. But yeah, I'd just like to say thank you, Philippa. That was really, really interesting, and I know I learned a lot, and I hope everybody else did too. So thank you, everybody, for coming along, and we will, I guess, see you in the new year. So yep. Merry Christmas, everyone.
I'll get Kirsten to send out that link to the video of Kareela Creek as well, if you want to watch it in your own time.
Yeah, sure. Do you want
to bit out of time?
Do you want to copy that into the chat, the URL into the chat? Is that possible?
I think so. Like, I can play it on the exit, but
sure, maybe do both. Maybe play it on the exit, but copy it into the chat.
Yep. Okay. Well, I'll put it up. I'll play it. But if you have to go, you have to go. And yep. And thanks everyone for listening.
Thanks, Philippa.
No worries. Okay.
Thanks, Philippa. That's great. Okay. Bye,
Oh,
everyone.
Awesome.
Oh. All right.
Okay.
Thank you, everyone.
Thanks.
Bye.
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 Bye.